This is lesson 1-5 on equations, and you can follow along with me in your textbook on page 33 if you want to. I'm just going to talk about the vocabulary, and then I'm going to go over a couple of the homework problems that you will find in ALEX. So in the vocabulary, we have some words like open sentence, and that is just something like 3x plus 7 that doesn't have an equal sign. We have the word equation, and that is something like 3x plus 7 equals 13. Notice equation, equal sign. And they talk about solving, which is just finding numbers that are true, meaning that they work. So for example, in 3x plus 7, if I were to plug in a 2, instead of x, I get 3 times 2 is 6. Plus 7, which does equal 13. So the number 2 is a solution to 3x plus 7 equals 13. We're also going to use the term replacement set, and that is just in this case a set of numbers that you are given that you may choose from. So some of them might work and some of them might not, but you're not going to choose from all the numbers in the world. You will be choosing from the replacement set that you're given. We're going to talk about sets, and that's just a collection of numbers or objects that are in braces. Braces are these squiggly things. And we're going to talk about elements, and elements are just each number in a set. So in this case, in this set, the numbers 2, 3, and 4 are elements. The solution set is going to be of the replacement set you're given. The solution set are the numbers that actually work. In this case that I gave you, a set of 2, 3, and 4, only the number 2 actually works in our equation that was 3x plus 7 equals 13. All right, so in this lesson, the big question is this: is it a solution? So you're going to be testing out numbers. And so in order to tell me which are solutions, you are going to need to take the numbers, each number, and plug it in. So in ALEX, you have a problem like this. It says for each value of W, determine whether it is a solution to W minus 33 equals 7. And you're given some numbers. You're given W and a list of numbers like this: 38, 37, 40, 56. And you actually have to mark yes or no. I'm going to add an extra column here for demonstrating, but you are going to be just checking the box yes or no. So if we're looking at this, the number 38, I'm just going to take it and plug it in for W. So I'm going to do this math. 38 minus 33, and does that equal 7? So have your calculator handy, and you can do this math. 38 minus 33, and we will get 5. And so we will check, no, that does not give me 7. It has to give me 7 in order for that to be a solution. Then I'm going to take 37 and do 37 minus 33, and that will give me 4. So no, that doesn't equal that either. I have the number 40, and I'm going to do 40 minus 33 equals, and that does equal 7, so I'm going to put yes. 56 minus 33 is actually 23, and so that would be a no. So you're just testing out numbers is all you're doing there. You're not actually doing any algebraic manipulation, just testing to see if the number is a solution and showing that you understand that a solution is a number that actually works. I'm looking at a slightly more complicated problem that looks like this, and it says for each value of y, determine whether it is a solution to negative 66 equals 6 times y minus 3. That's a little bit more complicated equation, but I'm still given, I'll go ahead and put a little extra space here. I'm given a 3, a 1, a -8, and a -5. And so I need to plug in the 3 to this equation. I'm going to say 6 times 3 minus 3. And notice I'm just going to work over here to see if I get -66. 3 minus 3 is 0, and 6 times 0 is 0. So that does not equal -66. So I will put no. And then I'm going to plug in this 1. 6 times 1 minus 3 equals, you can use your calculator for this also. 1 minus 3 is -2. Times 6 is -12. That does not equal -66, so that's no. 6 times -8 minus 3 is -11. Times 6 is -66. Yay, look what we just found, one that works, so that is a yes. And 6 times -5 minus 3, which is -8. Times 6 is -48, so no, that one doesn't work either. So all you're doing is checking to see which numbers actually work. All right, then I have a problem that says fill in the table using the function rule. Okay, so don't let the word function rule mess you up. That is just a vocabulary word that means basically the equation that we're using. So in this case, I have this, y equals 21 minus 2x. That is my function rule. It's just telling me what to do with my numbers. And I have a table that looks like this. And I have an x and a y. And they've given me 1, 2, 3, and 5. So I am going to just fill in the table with the values that come out here. Notice that I have 2 variables now, so I'm not actually checking to see if one particular number works or doesn't work. There are infinitely many combinations of numbers, x's and y's, that can go in here. And so it's likely that each number will have a particular number that goes with it. Each x will have a particular y that goes with it. So here I'm going to do this math. 21 minus 2 times 1. So I do 21 minus 2 is 19. And then I'm going to do 21 minus 2 times 2. See, I'm just plugging in the number from the x column into the actual x and then doing the math. 21 minus 4 is 17. 21 minus 2 times 3 is 21 minus 6. Again, you can have your calculator handy. This isn't a mental math test. 21 minus 2 times 5 is 21 minus 10, and that would be 11. So notice that this is a pair of numbers. 1 and 19 work together. 2 and 17 work together. 3 and 15 work together, and 5 and 11 work together. We could plot these numbers on a graph and we could connect them, and in this case this would make a line on a graph, a perfectly straight line. The next problem asks me also to use a function rule to fill in the table, and it has y equals -10x plus 1. And then I have a table with an x and a y, a -5, a -1, a 0, and a 1. And I'm just going to be plugging in these numbers. -10 times, instead of x, I'm plugging in a -5 plus 1. And so I have actually 50 plus 1 is 51. I have -10 times -1 plus 1. Again, have your calculator handy. This isn't a mental math or positive and negative numbers test. I have positive 10 plus 1 is 11. And then I have negative 10 times 0 plus 1. 0 plus 1 is 1. Negative 10 times 1 plus 1 is negative 10 plus 1 is negative 9. So I get these pairs of numbers that work together. Negative 5 works with 51, negative 1 works with 11, 0 works with 1, and 1 works with negative 9. And then in the last type of problem, I have a word problem. And it says, an amusement park charges an admission fee of $30 for each person. Let C be the cost in dollars of admission for P people. Write an equation relating C to P, and then use this equation to find out the cost of admission for 17 people. So my equation, every time a person wants to go to the amusement park, they have to pay $30. And so I am going to have to pay $30 per person. So I'm going to do 30 times the number of people equals my cost. Does that make sense? If I were to plug a 1 in for P, it would cost me $30. If I were to plug a 2 in for P, it would cost me $60. 3 people would cost $90, and so on. Okay, so that's my equation. And then it wants to know the cost for 17 people. So if I want to figure out the cost for 17 people, I'm going to plug in 17 for P and solve that. And I have 30 times 17, which equals $510 is my cost for all those people going to the amusement park. All right, so you can do these exercises in ALEX for lesson 1-5.